Hi, Ryan Kircher here with RMS Company. I'm here with Derek Keene and Brett, our engineering manager, Brett Sobczak, and we're going to be discussing some of the advanced finishing, post-processing, and cleaning steps that we do with our additively manufactured parts. So Derek, can you kind of give me an example workflow that we would see with like an additively manufactured spinal implant?
After the parts are removed from the build plate via EDM, the parts typically come to this room, get the struts removed and deburred, and then go out to hip, come back, we machine, laser mark, blast, clean, and passivate the parts.
And does all of that happen here at RMS?
The only thing that doesn't happen here at RMS is the hipping process.
So we do everything but hipping here, and hot isostatic pressing is a heat treatment that's necessary to achieve the right material properties for our titanium alloy. Do we do any inspection and things like that here as well?
So we have full capabilities for inspection equipment from microviews to CMMs.
Are there any other processes that are more atypical that RMS offers for our customers?
We do some assembly, some anodizing, and then some other forms of tumbling or blasting.
So Brett, do all of these post-processes need to be validated for every new product that RMS manufactures?
Typically we do a validation for processes. Some of those validations are customer driven or RMS owned. Those validations can be reused if they're RMS owned based on the product for various customers.
Can you give me an example of an RMS owned validation for a particular process that customers can leverage?
So we have a pretty extensive cleaning validation that we actually make coupons internally that can be run through the whole process and grasp the majority of the cleaning requirements set forth by our customer.
And what do those cleaning coupons look like?
So they are a coupon that's designed and manufactured at RMS that contains porous surfaces, lattices, gyroids, machined features, wire EDMs, processes that Derek mentioned go through the entire process here at RMS.
And those types of features are ones that we would just typically see in an additively manufactured part, is that right?
That's exactly right.
Brett, are there any new or developing post-processes that RMS is looking into bringing in-house?
We look into processes based on what the customer's needs are. So if there are ones that are specific to a customer's need, we can go and explore those operations. One example would be surface technology that's done on the nano level of the product itself.
Brett, Derek mentioned that you guys don't do hot isostatic pressing in-house here, and we send that out to a vendor. Can you explain why?
The process of hot isostatic pressing is a very time-consuming and expensive process. This is something that we've explored the option, but currently it's not what we're going to bring in-house.
Brett, we talked about a bunch of different processes, from laser marking to hand finishing to cleaning. Those seem like a lot of different processes. Why did RMS decide to bring all of those processes in-house?
The main reason is it really helps our customers. We can do it in a cost-effective method, and we can reduce the lead time to get the products to our customer faster.
From the engineering standpoint, we can always keep a close eye and make improvements on the process.
Derek, are all of these post-processes manual processes like deburring and blasting?
Yeah, some operations are manual and will always be, like our deburring, but going forward, we always look into new technology like blasting and making that automated. With this blasting, we are able to blast at a constant pressure and make a seamless finish.
Can one of you guys go into a little bit more detail about the automated blasting process?
So like Derek was saying, since we are using code, we can have a consistent and repeatable process, which makes it a good, suitable process for validation.
Brett, what kind of blasting media do you guys use in your automated blasters?
So we use Caber, which is a water-soluble media. We like that media because it's something that can actually be removed out of the porous surface once it's under a water bath. That's important because we want to make sure that there's nothing added to the part that you can't take out at a later time.
Well, Derek, Brett, thanks for taking the time to talk with me today. I think it's been very educational to learn about some of the advanced post-processing and cleaning steps that are necessary to manufacture additively manufactured medical devices.